Okay, so the paper that I chose to present is Human AI Collaboration by Conditional Delegation. I think it's the newest one, published in CAI 2022. So the main research question that they asked is, how can the imperfect models be used effectively in collaboration with humans? So why human AI collaboration? I think we already know why human AI collaboration we used nowadays because of so many reasons. So one of the reasons is that it has been used in human decision-making process across a broad range of domains over the past few years. And another reason why human AI collaboration is necessary is because there are many domains, especially the high stakes domains where full automation is not possible and feasible because of the limitation of the AI and also because of the other reasons like safety and ethical reasons. And another very important reason why we cannot go with full automation is because there is this problem called distribution shift problem, which says that most of the ML models actually work quite well in the in-distribution examples, for instance, on the training examples. But when they face, when we deploy these models to the actual world, real world, then they must need to tackle the out of distribution examples, and then their performance significantly drops. And this is the area where human AI collaboration can help to improve the performance of machine learning models in the out of distribution examples. And of course, we know that AI has been used in many areas to assist human decision making. For instance, in the case of in the criminal areas, where the judges predict whether a person will recidivate in the near future. Even for the human judges, this task seems to be quite difficult to analyze. So that's why it's really important that we combine human AI to assist this process, because AI can provide us with more insights that may human cannot produce. And most of the pure work in this human AI collaboration has focused on the high stakes decisions, for instance, the medical diagnosis and justice system. In the high stakes domain, actually the job of the medical professional or the judge is to go through every decision that the ML models make to make a proper informed actions. But there are several examples where this is not feasible. For instance, if you look at the Reddit, where different moderators use content moderation to filter out the toxic comments or other kind of comments from the mainstream, then making decisions on every action that the ML made is not feasible, is not scalable as well. So human AI collaboration on every single decision is not scalable and is thus less operated for tasks involving a large amount of relatively low stakes decisions. So in the Reddit application, what the content moderators do is they use auto moderator application, which is a rule-based system to automatically identify comments for deleting or reporting for further review. So it works as follows. First, they create a manually rules. These rules are nothing but keywords that these moderators use to filter out toxic comments from the non-toxic comments. And then they deploy this model, and it works as follows. Like if a comment contains a certain word, then it will be considered as a toxic, and if it doesn't, then it will not. So as I written on the bottom, if a comment contains word X, that comment will be reported. So it's kind of a report all process where you define a word, and based on that word, you actually filter out all the comments that contains that word. But this technique is not really, this is a hardcore technique, and it doesn't work in the real world scenarios. So these are what these authors propose is a technique called conditional delegation. What it does is actually combine human intelligence with the machine intelligence to first identify the delegation conditions. So what these delegation conditions are, these are also simply rules, keyword-based rules, but this time they also use the prediction of the machine learning along with the with the word that the moderator is going to choose to determine whether a particular post is toxic or not. So it combines both the human intelligence and machine learning. So if a command contains word X and is predicted toxic, the model will be trusted to report the command for the moderation action. Excuse me. So in the first process, both human and machine works together to identify the trustworthy region. So what they call is trustworthy region is the region where both human and machine agrees. And then they deploy this model and they only accept those answers that that relies in the trustworthy region, and then the other excuse. I'm still recovering from the fever, so I'm sorry for that. So for the other regions, they set it to the manual review process. So what they do is they use two types of distributions. So first they train the model based on this the data set of the Wikipedia comments. They call this wiki attack. That contains a different types of toxic comments, and they train their model on this. And they call this distribution as the in distribution examples, because this is the data set where they train their model. And the 70K commands were in the training set and 23 commands were in the test set. And then they also choose another out of distribution scenarios. Oh, sorry. Where they use Reddit. So this was not very, although it was resembled with the in distribution, but these were quite out of distribution scenarios to test how good their model works. And they also tested the performance on the in distribution, out of distribution scenarios, and they found that the model did not work really well on the out of distribution scenario. So they also kind of validate their approach in the paper. More details are in the paper. You can take a look at it. I just skip all of the model details because I just want to focus on the actual main contribution that they made. So they designed different kinds of interfaces based on the 4 different experimental conditions that I will explain in a minute. So this manual condition resembles what the auto detector works currently. It allows moderator to just enter the word that they think might have the element of toxicity, and then they add this rule to the system, and then system will filter out all the comments that contain that particular word. And then they use this predicted label. This also contains the conditional delegation approach that I described earlier in the paper. And they also included the predicted labels, like when the moderator search for a word, it lists all the comments that contains that word, but also with the label. And in addition to that, the moderator can also filter out the different comments based on their toxicity or non-toxic nature. You can also see that it also shows the total number of comments that belongs to the toxic category if the if the moderators filter comments based on this toxic or non-toxic label. And then there was another condition. They included the local explanation as well, drawing from the explainable AI technique. So in addition to all of the features that the previous two interfaces has, they also included the local explanation in the form of highlighting some most influential words that contributed to classifying that comment as toxic or non-toxic. And then in addition to the previous three conditions, they also included the global explanation, which is kind of a more general behavior of the algorithm to identify all of those words that the algorithm think could come under the category of toxic nature, and then also provided at the top to assist the end user, to assist the moderator to also take care of these words while deciding a comment as toxic or not. So they can also use these words in the filter category and use this as a rules. So this was the task design. There were 4 experimental conditions, as I described in the previous slides. There were 240 mechanical turkers they used, and for each condition they used 30 turkers. And since there were also 2 distribution types, as I described earlier in the slides, in distribution and out of distribution examples, so in total there was 240 turkers. And the procedure was simple. First, they presented them with a consent form and introduction, tutorials, and then the actual task, and then finally they presented them with some exit servers. So since the main goal was to improve the precision, which is the proportion of correct positive predictions of the model, and also the coverage, which is the proportion of a data set for which a classifier makes a prediction where conditional delegation. So therefore, they also made this average precision as one of their evaluation measures. It reflects the average quality of every single rule a person provides. And then there is a formula underneath you can see. And then they also made a success criteria based on the difference between the true positives and the false positives, like the number of reported toxic comments and the number of reported non-toxic comments. So it means that if their rules were able to find more true positives as compared to the false negatives, then it shows that they were successful in applying their rules. Efficiency means rules per minute, the number of rules added divided by the elapsed time. So this was pretty straightforward. And they also logged different kinds of actions, like the total time that they spent, and whether they used all of the options, they explored the user interface well, and the number of rules they added. So now I will discuss the results. As you can see on the screen, in terms of the average precision, the conditional delegation condition, which you can see on the screen in the form of blue bars, outperform the manual conditions in all of the 3 conditions as compared to the manual condition. And this dashed lines show the precision with the model working along. So that means is human AI collaboration along with this conditional delegation approach that they recommended outperform either the manual condition or the model working along. And this blotch, one thing that I forgot to mention is the wiki attack is the in distribution scenario, while the Reddit was the out of distribution scenario. And similar results were also, they found similar results in case of the out of distribution samples. From now onward, I will only focus on the in distribution scenarios, because in the out of distribution scenarios, the performance of the system was not really good. So this is something that I will explain at the end of the presentation. So this is the reward, the difference between the false positives and the false negatives. As you can see on the screen, the conditional delegation approach that they proposed outperformed the manual condition. And this shows that human plus AI always perform well with either human or AI alone. And in terms of efficiency, as you can see, which we define as the rules per minute. In case of the predicted labels condition, it was slightly lower. But as you can see on the screen, as they added more explanation to the interface, the efficiency improves. And in case of the global explanation, the efficiency was higher. Excuse me. So in order to test whether there was an overlap between the, because as I said earlier, in the global explanation condition, the model presented some most influential keywords that the moderator may use to better construct their rules that may filter most of the comments, which can also cover the which can also address the coverage of the model. So they also determine whether there was overlap between the keywords that the global explanation provides with the ones that the human used. So in this illustration, you can see that there was indeed an overlap with the human created rules and the global explanations. And this shows that providing explanation, especially in the form of the global explanation, where model presents choices generally, regardless of the particular instance, might help moderators to better construct rules that that filter out most of the toxic comments. In terms of the engagement, there were also similar results. Conditional delegation again outperformed the manual condition. And in case of the predicted labels, the engagement was much higher than the other conditions. So one of the key takeaways that they mentioned in the paper was that conditional delegation is a promising alternative paradigm that allows users to control when to trust or distrust AI and helps to achieve complementary performance. However, one thing that I want to mention here is that these all of the conditional delegation only works well on with the in distribution scenarios, in distribution examples, not with the out of distribution scenarios. So there is still a lot of work need to be done in the scenarios where we can use similar approaches in the out of distribution scenarios and improve their performance. Although the narrative of the authors at the start of the paper was that they want to use this approach to improve the out of distribution or imperfect models, but I think this is not this was not the case as I observed in the paper. So the model only improves the in distribution scenarios, and there is still a lot of work need to be done to apply similar approaches to the out of distribution scenarios. Yeah, this was the presentation. I'm sorry for the disturbance. I'm still recovering from the fever and flu, so I was not in my full potential.